So I'd like to start with an example. I'd like to take problem number 10. Directions here, slightly different. Directions, change the Cartesian integrals into an equivalent polar integrals, then evaluate the polar. Well, let's see. This is rectangular. Integration is coming in heavily. And let's see how this works. So if I want to really figure out what this is, simple translation doesn't work. I really have to figure out what region are they talking about. And if I take a look at this, I'll notice that they're letting y run between 0 and 1. Well, y equals 0 to y equal 1. That's y equals 0. And that's y equals 1. And x is varying from 0 to x equal the square root of 1 minus y squared. We did come across this a bit. If you guys remember, we said this was x squared equal 1 minus y squared. That was in the previous section. Just how to write in this. Here we go. And we know this is a circle with a radius of 1, except when we say x is running from x equals 0, that's the origin, and the x equal 1 is a circle that really looks like this, but we are only interested in this quarter of the circle. So if I want to convert, I would say, well, that is the integral. X squared plus y squared is really r squared. And just to convert from dA, that is r dr d theta. Theta runs from 0 to pi over 2. And you're really going to draw arrows to figure out what r runs from. And r runs from the origin all the way to r equal 1, and that's pretty much it. And that's a simple integral. That's really r cubed divide dr d theta. So you could do the rest unless it's a complex integral, and we're going to have discussion on this in class, next class meeting. So if anything I write you can't integrate, I'll be more than happy to show you. Next problem on the list, I'd like to look at problem number 14. Let me see where that is. Here it is. And if I look at problem number 14, again, I want to convert from x and y to r and theta, and let's see how this works. So I need to kind of visualize this region to figure out what they're talking about. And if I look at this, this says x runs from x equals 0, this is x equals 0, to x equal 2, this is x equal 2. And y runs from y equals 0, so y equals 0 is this, to y equal x. So they're talking about this region. I want to convert this to r and theta. Well, let's see. The price for eliminating dA, which is dy dx, is r dr d theta every time you convert, and we know that y is r times the sine of theta. And now comes the region. How am I going to do this in terms of r and theta? So the rotation, well, if the angle is this simple, that is y equal x, I know the angle runs from 0 to pi over 4 because that's where y equal x. And then r runs from 0, we just solved that. X equal 1 happen to be r cosine of theta equal 1, r equal 1 over the cosine of theta, which is the secant of theta. And this is nothing more than r squared the sine of theta. You could really solve that. That's not that challenging. Again, if you have a question on that, ask me in class. I'll be more than happy to show you. the next example on the list. So I want to try and set up as many of those as I can. I'd like to go over number 16. Normally, in class, I would say here, you guys try it. You guys could pause this for a minute. Anytime you need, you could pause the video, and then you could just try and work it out, set it up, see if you could get it, and match it with what I have. Again, you need the graph first. Again, keep in mind, I am going to upload this PDF, so you'll have all of this work in front of you. I suggest you really try and set up some of those without looking at the notes. So again, I need to figure out what this graph looked like. You know what? Let me shift this up a bit. And let me shift this to that a bit. And maybe make it bigger. Here we go. So again, we're looking at trying to figure out what this is. When we say x equal the square root of 4 minus y squared, hopefully by now we are comfortable with recognizing that this is the right half of a circle with a radius of 2, right? And let's see how this works. They really have some limitation. They want y equal radical 2. Radical 2 is 1 point sum to y equal a 2. And they say x is going to run from this circle to x equal y. X equal y. They're talking about this region of the circle. I'm sorry, they're talking about this region of the graph. So they're really talking about outside of the circle. And what we want to convert this to x and y. Well, first things first, we already know how this plays since we're converting r d theta. And there's nothing in there because there's a 1 for matching this one. Now, when we want to really convert this to rectangular, we need to really set this running from theta equal, y equal x is really theta equaling pi over 4. And it's going to run all the way to pi over 2, it seems. And if I take r, I'll notice that r is going to start always on the circle, and the circle has a radius of 4, so it's going to run from r equal 2, radius of 2, and it's going to end on this line, and this line is x equal y. I'm sorry, that's not x equal y, that's the line y equal. That's the line right there of y equal 2, and if I replace y by r, the sine of theta, that would mean r equal 2 over the sine of theta, which is twice the cosecant of theta. That would be twice the cosecant of theta, and there it is. Again, those are linear integrals. We could do those, not a whole bunch of work. Next problem I'd like to look at is number 18. And again, I suggest you pause this video, work out this problem first, and see if you could come up with at least a graph. That's the key for you getting this. So this is, again, this is really the troubling part. Y equal the square root of 2x minus x squared. That's really y squared equal 2x minus x squared. That is x squared minus 2x plus y squared, completing the square, x minus 1 squared plus y squared equal 1. I am aware that it's a circle with a center of 1, 0 and a radius of 1. If I was to get the whole graph, but I'm not going to get the whole graph. Now, if I look at the limitation, x runs from x equal 1, there's x equal 1 to x equal 2, and y runs from 0 to this circle, so they're talking about this region only. Now, the conversion unit, if I convert, I already know that this is r dr d theta, that's fixed. And if I convert this portion, that will be 1 over r squared squared. What's left is for me to really figure out the angle runs from what to what. The angle is going to run, which is theta. Theta is going to run from 0 to where those two meet. Remember, this is the line x equal 1, right? And x equal 1 really works as secant of theta. We already figured that out. And this point is 1, 1. Oh, I'm sorry. We're talking about theta. This is 2 pi over 4. That's because they're equal. Now, this runs from 1 to the circle. From x equal 1. X equal 1 is really the secant of theta to the circle. And the circle is really twice the cosine of theta. And I can get that from this equation right here, where it says x squared plus y squared equal 2x, or simply r squared equal 2r the cosine of theta. And if I get everything on one side, 0 on the other side, and factor an r out, I'll get r to equal twice the cosine of theta. Okay, I want to do 2 more, but it seems YouTube is limiting me to less than 15 minutes. I'm going to stop this video here and pick it up in the last portion.